Hi, welcome back to my channel. My name is Gina. In this video, we are going to look at Newton's first and second laws and different types of forces. Let's start with Newton's first law. Newton's first law says, a body remains at rest or at constant velocity if no force is acting on it. For example, if you are standing on the train and the train is at rest, then if the train starts to accelerate forward, then you'll lean backward because there's an acceleration on the train, but there's no horizontal forces acting on you. So you'll tend to remain at rest. So your movement will be backward relative to the movement of the train. Similarly, if the train is moving at a constant velocity, then it deaccelerates. But there's a horizontal force acting on you, so you remain at the constant velocity, which is the velocity of the train before it deaccelerates. So in that case, you'll tend to lean forward. And Newton's second law further says the force is proportional to the acceleration. The law states that if there has a force, then there has an acceleration. And the relationship between the net force and acceleration is net force equals to the mass of the object times the acceleration of the object. The net force here means the sum of all forces applied on an object. A quick note, force and acceleration are vectors, which means they have a magnitude and a direction. And the proportionality here is the mass of the object, which means if you have two objects, mass 1 is greater than mass 2, then in order for them to have the same acceleration, you need to apply more force on mass 1, the heavier mass. Now let's look at different types of forces. Remember that a force is a vector. So for each of the forces, we'll discuss its magnitude and direction. Let's start with the gravity force. And here we'll focus on the gravity force on Earth. Its magnitude is the mass times the gravitational acceleration, g. And this g at the surface of the Earth approximately equals to 9.8, and the unit for acceleration is meter per second squared. And this is an approximation at the surface of the Earth. And the direction of gravity force is downward. So everything on Earth will tend to fall downward due to the gravity force. This is also the force that keeps everyone staying on the ground, so we are not flying around. Then the second force we are going to discuss is the normal force, which is a force when there's contact between two surfaces. Its magnitude is whatever it takes so that the object doesn't cross the surface. For example, if I put a box on the ground, what are the forces acting on the box? There is the gravity force that we just discussed, and the force is pointing downward. And normal force, its direction is perpendicular to the surface. And this is the force that prevents the object from sinking into the surface. So this force will be pointing upward. Now let's look at the third force, the tension force. This force is when an object is attached to a rod, and its magnitude is whatever it takes so that the rod doesn't stretch, and its direction is toward the rod. For example, if I hold a string, and the string is attached to a rock, then if I hold the string so the string is just naturally falling downward, then what would be the forces acting on the rock? So that is my hand, and I'm holding a string, and the rock is attached at the end of the rod. There's a gravity force acting on the rock, which is pointing downward. Everything on Earth has gravity force and is pointing downward. And the rock is attached to the string, so there is tension force that is pointing toward the rock. Let's look at one last force that we are going to discuss in this video, the friction force. There are two types of friction force, kinetic friction and static friction. Kinetic friction is force that happens between two surfaces in contact and they are moving relative to each other. Its magnitude is the coefficient of the kinetic friction times the normal force. And this coefficient depends on type of surfaces. And the direction of kinetic friction is opposite to the motion. For example, if I put a box on the ground and I give a push to the right, let's call this force of push. And due to my push, the box starts to move to the right with velocity v. What would be the forces acting on the box? Let's look at the vertical forces first. So everything on Earth has gravity force. So there's gravity force that's pointing downward. And the box is in contact with the ground. So there's a normal force that prevents the object from sinking into the surface. So normal force would be pointing upward and it's perpendicular to the surface. Furthermore, since the object is moving to the right, so there's kinetic friction that opposes this movement. So the kinetic friction will be pointing to the opposite direction of the movement, which is to the left. And the second type of friction force is static friction. This force also happens when two surfaces are in contact, but the object is not moving with respect to the surface. And the magnitude of static friction is smaller than or equals to the coefficient of static friction times the normal force. In other words, it's whatever it needs to be so that the object doesn't move up to a maximum, static friction max, equals to the coefficient of static friction times the normal force. And its direction is also opposite to the motion. For example, let's take the same box. And I'm pushing the box to the right. But in this case, I did not exert enough force so that the box starts to move. So the velocity of the box is 0. And force of push would be smaller than the force of push that I exert in the previous example. Vertical forces are the same. There is the gravity force that's pointing downward, and normal force is pointing upward. And the static friction would be the force that prevents the object from moving. So static friction would be pointing to the left, and its magnitude would be smaller than or equals to the coefficient times the normal force. And that is the end of the video. Next week, we'll look at two examples using Newton's second law. If you like my videos, please like and subscribe, and I'll see you in the next video.